In this example, we are going to make the amplitude controller IP using Vitis HLS 2022.1. So first we'll launch Vitis. So the amplitude controller IP takes as input a 32-bit value via the AXI light port and gives as output a 256-bit value using the AXI stream port. So we'll go to create project. Project name, we can keep it as click on next. Then these files we can add later. Next again, and then we have to select the board here. Click on finish. So first we're going to add source files. First we're going to add a header file. Right click on source, new source file. You can name this ac.h. Then we'll make the file that contains the top function. We can call that ac.cpp. Then we're going to add a test bench file. This will be called actb.cpp. So here we have all the libraries that are included. This is the size of the output. These are the number of samples. Because we have a 32-bit value as input, we are going to copy it 8 times, concatenate it, and then return a 256-bit value. So number of samples is 8, and this is the output size, stream packet, and this is the data size, input data size. So now here we are going to put the prototype of the top function. And we can save this. This is our header file. Next we'll move to ac.cpp file. So here first of all we have to include ac.h. So we'll do after this we have to declare our top function here, so we can copy the function declaration from here. Next we're going to declare the output packet and concatenated data variable. This is the concatenation operation which takes the gain value of 32 bits and concatenates it 8 times. And after that we're going to write concatenated data into the output stream. So this file is done, we can save this. So here also the first step is that we can include the header file. Then we can write the main function. So in the test bench, I want to generate a random 32-bit number and pass it to the amplitude controller, and then I want to see that in the output it is concatenated 8 times. So for this we are also going to include the math library for random number generation. Now we are going to generate a random 32-bit number. So in this line, the random function returns a 16-bit value. So we are going to take 2 of those 16-bit values. Next we are going to create the ground truth value by concatenating this value 8 times. So after the ground truth, we're going to declare a variable for the IP output, which is going to take the value which the IP returns. We're going to declare an output stream and an input variable. So this input is going to get passed to the IP. So we can set input as gain. Then we can call the function with the IP. So we can say AC input comma output. So since output is an HLS stream variable, we're going to read the value of output and store it in the IP output variable. Next, we're going to print the values of the IP output and the ground truth to compare them. This is for debugging purposes in case the code fails. Then we'll put the condition that if IP output and the ground truth are the same, then it is going to print test passed, else test failed, and it will return a non-zero value. And if the test passes, it will return 0 value. Now we can run this test once, or we can run it 5 or 10 times to see that the code is working properly. So here we can put a for loop which runs this code 10 times. And we can take this entire code and put it in the for loop. We should take out the return 0 from the loop, otherwise it will return 0 after just one iteration. And we can put it here. So now our code is good to go. We can save this file. And then we can click on C simulation and run the simulation. So here we can see that the CSIM passes, and this is the IP output and this is the ground truth, and they're the same, and this value has been concatenated 8 times. Next we can run the C synthesis. So now for C synthesis, we have to set the top file. For that, we'll go to project settings, synthesis, and then we can browse the top function. Click on OK. Then we can run the C synthesis. Click on OK. Make sure the board is correct. So the synthesis is done. Next we can run the co-simulation. And in co-simulation we have an option to dump trace. We're going to select all. So what this will do is it will give us a waveform result that we can see how our IP, all the signals are working. So that is very useful for debugging. So now the co-simulation is done, we can go to the wave viewer and we can see all the signals here. So go to design top signals, go to see inputs, inouts and outputs, and here we can see the gain signal. So this is these are all the values of the input gain signals, and here we can see the output data. So we can see that this value has been concatenated 8 times successfully. Like this. We can see it for all of these values. We can close the wave viewer and we can then export RTL. So what this does is it makes our IP into an IP that we can import in Vivado. So here we have to set the file location. Click on OK. So once this IP is exported, we can import it in Vivado and then we can use it to make a block design. So now RTL exporter implementation is done. We can see it in our file system. If we go to the folder where we have saved our design, then we can see that this export.zip is there. So in the next video, I'll show you how to import it in Vivado.